Hi, this is Mrs. Slater, and today we're talking about imaginary and complex numbers. In the set of real numbers, negative numbers do not have square roots. An equation like x squared equaling -1 has no solution. So that's why imaginary numbers were invented, so that negative numbers would have square roots and certain equations would have solutions. These numbers were devised using an imaginary unit called I, in the agreement that I squared equaled a -1 or I equaled the square root of a -1. So maybe this joke will make more sense because we assume that I acts like a real number in other respects. Square roots and all negative numbers can be expressed as the product of I and a real number. So in the cartoon, hey, you guys want to meet my new friend? Sure, but where is he? He's right here. Why can't anyone else see you? Beats me, because there it is. Square root of -1 is imaginary. So let's go ahead and start some problems. We're going to express each in terms of I. So we're going to separate what we now know can be solved. For example, this one, we have the -1 and the 4. This is I, and we know square root of 4 is 2. And just like I for any variable, we're going to end it with I being in the end of the term instead of the beginning. This one, a little tricky just because we split this into a -1 and 3. The I is square root of -1. Square root of 3 does not break down, so we're going to have to leave it in our answer. Okay, and then in this case, the I is going to be in the front because the square roots are always in the back. Okay, and then on this one, the -1 and the 12 break down into I, square root of 12, but the square root of 12 breaks down. So you must simplify as much as possible. And then I times 2 would look like this. And to clean it up, we'd put the 2 and the I first, and then the radical 3. When adding and subtracting complex numbers, treat the variables the same as we always have done. And what I mean by that is you take the leading coefficient and go ahead and subtract those. So you have 7, and then the I is going to remain in the answer. Okay? And this one, 3 plus 4 is 7, so we again get 7I. And on this, we're going to have to distribute that negative so we do not make any mistakes on what the signs are. So 6I minus 2I is 4I. And then 4 minus 1 ends up being 3. So 4I plus 3 would be your answer. Go ahead and push pause for the next two. See if you can get the correct answer of 7I plus 4. And see if you can get -6I minus 8. And we'll check those in class. Okay, and then the last thing we're going to do, last topic, is multiplying complex numbers. So we're going to use an I clock when necessary, and then I'll come back to that in a second. So for example, let's put all of this together. 3 times 2 is 6. I and I cubed and I, there's an invisible 1, gives us a total of I to the 4th. So now let's go to the I clock that's on your page. The first 4 powers of I establish an important pattern that should be memorized. And I'm hoping the I clock will help you with that. For example, I to the first power is equal to just I. Now, if you wind around the clock, this I squared is going to equal a -1, and -I is going to equal I cubed, and the very top is going to equal I to the 4th. Okay, now the reason those 4 need to be memorized is because all real numbers, anything that I is 2 is going to be one of the 4. So that's why it's very important to memorize. Now, why the clock is important is because, well, for the first example we had, I to the 4th is simplified to 1. So we can simplify this even farther than it was before. Okay, now we'll go back to the I clock every once in a while, and I'll show you where you're going to need it the most. Here on this one, if you separate the square root of -1 and 2, and the square root of -1 and 10, 10 and 2 is 10. 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 10 and 2 is let's see what we have left over. Here we have an I, square root of 2, another I, square root of 10. And if we put all of the i's together, we have I cubed, and the radicals together are going to give you a radical 20. So again, simplifying means you can't have any square roots inside. And I know square root of 4 goes into 20. So I'm going to continue over here. So I'd have I cubed times 2 times radical 5, I cubed, sorry, or I cubed times radical 5. Now if you go back to your I clock, what it says is that I cubed equals negative I. So we can simplify this to 2, and I don't need parentheses there, 2I square root of 5 and a negative, because it was negative I for our final answer. Okay, let's go ahead and try the next one. Negative is going to be taken out of both of them, leaving us with I radical 5, I radical 3, and that multiplies together to give you I squared and radical 15. And then if we look at our clock, I squared is a value of negative 1. So we will simplify this and put negative square root of 15. So for the next ones, the I clock is even more important because there's such large numbers and you're not going to want to do this by hand. So the first one, I to the 16th, is a multiple of 4. So anything that's a multiple of 4 is going to have a value of I to the 4th, which then is 1. So I to the 16th, and this is the way I want you to look at the rest of them, because sometimes you can't tell if the number or the exponent is a multiple of 4. So what I want you to do is take the exponent and divide it by 4. Every single time, divide by 4 because the pattern is in 4s. And you get 4 with a remainder of 0. So the way I like to look at it is, well, if there's no remainder, it's just going to be I to the 4th. Okay, now let's go ahead and write that in. So this is just 1. Now for the next one, 26, I to the 26th, we are going to take 26 and take 4 and divide into it. Well, we all know that 4 times 6 will give you 24, and you have a remainder of 2. So anything with a remainder of 2 is going to be the same as on the clock, where you have I to the 2, well, that's going to be a negative 1. I to the 26 is the same thing as saying negative 1. So let's go ahead and write that in here. Okay, next one is I to the 105th. Let's see what happens here when we divide by 4. So we have 2, 8, 25. 4 goes into 25 6 times, leaving us with a remainder of 1. So if there's a remainder of 1, that's the exact same thing as I to the first power, and that's going to be I. So you're always going to get one of the 4 answers in the I clock. It's either going to be 1, I, negative 1, or negative I. No other exponents are allowed. Okay, so again, review. This one is I to the 1st, I to the 2nd, I to the 3rd, and I to the 4th. As long as you remember it's in that order, then you will be perfectly, you'll do really well. Now another thing, if you don't like to do these by hand, let's say we use our calculator instead. So we would take 16 divided by 4. Again, everything is multiplied by or divided by 4. And you get no decimal. So therefore, the answer is 1. The next one, 26 divided by 4. You get 6.5, which is halfway around the clock. So if you want to look at it that way, halfway around clock is negative 1. The next one was 105 divided by 4. And you got 26.25. Well, 25 is a quarter past on the clock. So that one is going to be I, or the same value as anything in that spot, I. Okay? So hopefully that gives you a better idea. I want you to look at the next 3 and go ahead and solve those. and have them all done by class time. And that's where I'm going to end today. So this concludes this lesson.